Now, given this table, and we need to use SRTF scheduling algorithm, and then we need to find out the average waiting time. Okay, what is the average waiting time? That's what is given in the problem, right? Fine. Let's draw the Gantt chart first, as usual. Our Gantt chart will start with time unit 0 always. Fine. At time unit 0, the only process which has arrived is P1, right? So I am going to schedule process P1, and P1 will execute at least till time unit 3, okay? Because only at time unit 3 some process is coming to the RAM. Fine. Now it has executed for 3 time units, so I am making the 7 as 4. Fine. Now out of only P1 and P2 are inside the RAM, right? Now out of P1 and P2, the process with the highest priority is nothing but P2. So P2 will be scheduled after preempting P1, and P2 will execute at least till 5, right? Because at 5 P3 arrives. Now this becomes 1. Fine. Now we have P1, P2 and P3 inside the RAM, out of which the process with the highest priority is nothing but process P2 itself. So P2 will not be preempted. It will continue as it is at least till 6. Okay. Now only for 6, because this is done. P2 is completely done. Now at time unit 6 we have P1, P3 and P4, right? See, P2 is completed, and so it is removed from the RAM completely. Now we have only P1, P3 and P4 in the RAM. Now among these three, the process with the highest priority is nothing but process P4. So P4 will be scheduled until 8. Fine. Now this becomes 0. Fine. Now out of P1 and P3, the process with the highest priority is nothing but P1. So P1 will continue till 12. Okay. Now we have only P3. So we need to execute it in one go. P3 will be executing until 17, right? Now the question asks is, what is the average waiting time? Okay, just to compute waiting time, average waiting time, first let's compute the completion time so that it will be easier. Okay, this is P1, P2, P3 and P4. What is the completion time of P1? Completion time of P1 is at 12 time units. Completion time of P2 is at 6. Completion time of P3 is at 17. Completion time of P4 is at 8. Okay. Completion time of P4 is at 8. Fine. Now let's compute the turnaround time. Okay. See, we can compute the waiting time directly, but this is actually quite easy. Okay. You will not make mistakes. So it's better to go this way. Now let's compute the turnaround time. Turnaround time of process P1 is nothing but, see, we know that formula, right? Formula for turnaround time. Turnaround time is nothing but completion time minus arrival time. Fine. Now completion time is 12. P1 has arrived at 0. So turnaround time is 12. Completion time is 6. P2 has arrived at 3. So 6 minus 3 is nothing but 3. Similarly, completion time is 17 and P3 has arrived at time unit 5. So 17 minus 5 is 12. P4's completion time is 8. Whereas P4 has arrived at 6, so 8 minus 6 is nothing but 2. Okay, fine. Now let's compute the waiting time. Since IO time equal to 0, see, again for this problem we assume that IO time of every process equal to 0. Okay, since IO time equal to 0, our waiting time is nothing but turnaround time minus burst time. Okay. Turnaround time minus burst time. Now the turnaround time of P1 is 12 and the burst time of P1 is 7, right? 12 minus 7 is 5. Turnaround time of P2 is 3 and the burst time is 3. So 3 minus 3 is 0, which means it has not waited for any time. P3's turnaround time is 12 and P3's burst time is 5. So 12, I am taking this number, okay, these numbers. 12 minus 5 is 7. Similarly, P4's turnaround time is 2 time units, out of which it has executed for 2 time units, which means it has not waited for any time. So 2 minus 2 is 0. Okay. Fine. Now we have calculated the waiting time. Now the average waiting time is nothing but 7 plus 5, see if you add 0 it will remain as it is, right? 7 plus 5 divided by 4 plus 0 divided by 4, okay? So 12 divided by 4 which is nothing but 3. So average waiting time of all the processes is nothing but 3, okay, using SRTF scheduling algorithm. Fine.